Hello everyone, welcome back. Today I am here with the second part of this topic, that is plant-water relation. And in this part I will discuss some topics like osmotic pressure, importance of osmosis in plants, then what is turgor pressure, what is plasmolysis, and what is water potential and its associated terms. So these are the topics that I will try to cover in this presentation. Let's start. Firstly, what is osmotic pressure? So it is the amount of pressure that is required to stop the process of osmosis through a semi-permeable membrane. As we can see in this animated photograph, यहाँ पे हमारे पास इस तरफ solvent है और there is a semi-permeable membrane here and there is solute. So इससे जो पानी है, solvent है, ये move करता है through the semi-permeable membrane और जो इसका amount है that is increased, that we can see here. But if we apply a pressure on this side, so that pressure will stop the process of osmosis. So ये जो pressure apply होता है, this amount of pressure which is used to stop the process of osmosis or this movement of water through a semi-permeable membrane is known as osmotic pressure. इसे कहा जाता है osmotic pressure. So this is the pressure required to completely stop the entry of water. तो entry of water को stop करने के लिए जो pressure चाहिए into osmotically active solution across the semi-permeable membrane is known as osmotic pressure. इसको हम मेजर करते हैं एटमॉस्फेयर्स में, बार्स में और पास्कल्स में, और ये हम कैलकुलेट कर सकते हैं विद द हेल्प ऑफ वन फार्मूला, दैट इज पाई इज इक्वल टू ICRT. हियर पाई इज osmotic pressure, I is Van 't Hoff factor, C is the molar concentration of the solute in the solution, then R is the universal gas constant, and T is the temperature. So by this equation we can calculate this osmotic pressure. Then there are some instruments that can measure this osmotic pressure, that is known as osmometer, and there are different types of osmometer, like we have Berkeley osmometer, then Hartley osmometer, and Pfeffer's osmometer. So these are some instruments that are used to measure the osmotic pressure. Next comes the importance of osmosis in plants. So firstly, the water is absorbed by this process, that is osmosis, into the root hairs. As we can see in this animated photograph, जो soil particles हैं, इनके बीच में soil में पानी present होता है, and in this root hair there is high concentration of solute as compared to the soil water. So water will enter inside this root hair, and after entering into the root hair it will passes through different types of cells, that is like cells of epidermis, then cortical cells, and finally reaches to the endodermal cells. तो ये जो movement होता है cell to cell और soil से plant के part में, it is carried out by the process of osmosis. So entry of soil water into root is carried out by osmosis. Then cell to cell movement of water occurs again by osmosis. Here we can see here जो पानी है वो root hairs के अंदर enter करता है, then it passes through the epidermis cell, then to the cortical cell, and finally it reaches to the xylem vessels by passing the endodermis. Endodermis से एक ऐसी layer है roots में जहाँ जिसपे एक special thickening present होती है, जिन्हें बोलते हैं हम Casparian thickenings or Casparian strips. But there are certain endodermal cells which lacks these Casparian strips और बहुत ही कम होती हैं, और उनके अपोजिट present होता है प्रोटोजाइलम, और प्रोटोजाइलम के अपोजिट जो एंडोडर्मिस के सेल्स प्रेजेंट होते हैं जिनमें कि कैस्पेरियन स्ट्रिप्स एब्सेंट होती है, उन्हें कहा जाता है पैसिव सेल्स. दे आर कॉमनली नोन एज पैसिव सेल्स. तो इनके थ्रू पानी मूव करता है, और ये जो प्रोसेस है दैट इज ऑस्मोसिस. लिविंग सेल्स रिमेन टर्जिड ओनली बाय द ऑस्मोटिक एंट्री ऑफ वाटर इनटू देम. जो सेल्स हैं वो इंटैक्ट रहते हैं, टर्जिड रहते हैं बाय द एंट्री ऑफ वाटर. वेरियस सेल ऑर्गेनिज लाइक वी हैव माइटोकॉन्ड्रिया एंड क्लोरोप्लास्ट विल कोलैप्स. ये कोलैप्स हो जाएंगे क्योंकि इनके पास कोई भी स्केलेटन सिस्टम प्रेजेंट नहीं होता है. सो दे आर इंटैक्ट बिकॉज ऑफ द एंट्री ऑफ वाटर. जो प्रॉपर ऑस्मोटिक कंसनट्रेशन इसके अंदर होता है, इसकी वजह से ये वाटर को एब्जॉर्ब करते हैं, इसके अंदर पानी की एंट्री होती है, एंड दे बिकम्स इंटैक्ट. इनकी एक डेफिनेट शेप होती है. द नेक्स्ट 70% ऑफ द सेल वाटर इज हेल्ड इन वैक्यूल्स. वो प्रेजेंट होता है वैक्यूल में. वैक्यूल एक इंपॉर्टेंट सेल ऑर्गेनली है प्लांट सेल में. ये मैक्सिमम स्पेस को ऑक्यूपाई करता है प्लांट के अंदर. इसी की वजह से जो न्यूक्लियस की पोजीशन होती है दैट इज समवट एक्सेंट्रिक अवे फ्रॉम सेंटर, और इसकी जो मेम्ब्रेन होती है वैक्यूल की, उसे कहा जाता है टोनोप्लास्ट. that is called tonoplast. It has come from outside through endosmosis. जो भी सेल ऑर्गेनीज हैं उनके अंदर जो पानी जाता है that enters by the process of endosmosis, क्योंकि इसके अंदर सॉल्यूट की कंसनट्रेशन ज़्यादा होती है और पानी इसके अंदर एंटर करता है and is kept in its place due to osmotic concentration of solute dissolved. The next जो भी प्लांट पार्ट्स हैं, सॉफ्ट प्लांट पार्ट्स लाइक लीव्स हैं, फ्लावर्स हैं और फ्रूट्स हैं, ये भी इनकी एक डेफिनेट शेप होती है. दैट शेप इज़ इंटैक्ट बिकॉज ऑफ दिस ऑस्मोसिस. जो टर्जिडिटी होती है वाटर के एंटर की वजह से, इसी वजह से इसकी डेफिनेट शेप होती है. सो द सॉफ्ट ऑर्गन्स लाइक लीव्स, फ्लावर्स, fruits and young stems are able to keep themselves strengthened and swollen due to turgidity of their cells, which is dependent upon osmosis. और ये भी डिपेंडेंट है ऑस्मोसिस के ऊपर. ये बहुत ही इंपॉर्टेंट रोल प्ले करता है ग्रोथ ऑफ रेडिकल एंड प्लेम्यूल ड्यूरिंग सीड जर्मिनेशन. तो जब सीड जर्मिनेट करता है तो इसमें दो पार्ट्स होते हैं एम्ब्रियो के. एक होता है प्लेम्यूल और एक होता है रेडिकल. प्लेम्यूल विल गिव राइज टू द शूट सिस्टम और जो रेडिकल है दैट विल गिव राइज टू द रूट सिस्टम. तो ये रेडिकल और प्लेम्यूल की ग्रोथ के लिए भी जो इंपॉर्टेंट फिनोमेनन हेल्प करता है दैट इज ऑस्मोसिस. And basically there are two types of germination, seed germination. One is apigeal germination that we can see in this photograph. Here apigeal means जो cotyledons है ये soil के surface के बाहर आते हैं due to this excessive growth of hypocotyle, और ये push कर देता है इन cotyledons को out of the soil surface. और ये जो cotyledons हैं they act as first cotyledonary leaves, as we can see in the pulses. So this type of germination is known as apigeal germination, and there are many seeds जो कि ज़मीन के नीचे ही surface के नीचे रहते हैं, that is called hypogeal germination. So there are basically two types of germinations which are present in during the process of this seed germination, और इसमें important role play करता है osmosis. Then many plant movements like folding and dropping of leaves that we can see in this plant, that is Mimosa pudica. This is touch me not plant. इसमें जो leaves fold होते हैं जब हम इसको टच करते हैं, सो दिस इज़ ब्रॉट अबाउट बाय ऑस्मोसिस. ये भी ऑस्मोसिस की वजह से होता है. देन ओपनिंग एंड क्लोजिंग ऑफ स्टोमेटा. जब पानी एंटर करता है गार्ड सेल्स में तो ये जो सेल्स हैं दे बिकम टर्जिड और ये जो स्टोमेटा है ये ओपन होता है. व्हेन द वाटर इज लूज्ड बाय दीज गार्ड सेल्स देन दीज सेल्स बिकम फ्लैसिड एंड स्टोमेटा गेट्स क्लोज्ड. So the stomata opens and closes only in response to increase and decrease in osmotic pressure of the guard cells in relation to nearby epidermal cells. For this opening and closing of stomata, osmosis plays very important role. So these are. The next term is turbulent pressure. So this is the hydrostatic pressure which is developed inside the cell when water enter inside the cell, and this pressure is exerted towards the outer side of the cell, means from center towards the cell wall. So this hydrostatic pressure which is developed inside the plant cell by the entry of water is known as turbulent pressure. Pressure that develops inside a cell due to osmotic diffusion of water inside the cell is known as turbulent pressure, and it helps in maintaining normal physiological activities. जो भी leaf की shape है, flowers की shape है, petals की shape है, so that shape is maintained by this turbulent pressure. So the pressure exerted by the cell's fluid, basically जो cell के अंदर fluid है, against the cell wall, जो cell wall के against pressure apply होता है, that hydrostatic pressure is known as turbulent pressure. Then जो cell wall है that is solid, तो ये जो cell wall है ये opposite pressure exert करता है on this plasma membrane, so that opposite counter pressure is known as the wall pressure. So counter pressure is known as wall pressure that develops inside the cell which is equal but opposite to the turbulent pressure. So we can see here, so we can say that in a fully turgid cell this turbulent pressure is equal to wall pressure. That is turbulent pressure is equal to wall pressure in a fully turgid cell. Next is plasmolysis. So this is the process of shrinkage of this protoplast when the cell is kept in hypertonic solution. जब हम किसी सेल को हाइपरटोनिक सॉल्यूशन में रखते हैं तो जो उसके अंदर का सॉल्वेंट है वो बाहर आ जाता है, दैट इज़ बाय द प्रोसेस ऑफ एक्सोऑस्मोसिस, और उसके रिजल्ट से जो प्रोटोप्लास्ट है वो श्रिंक हो जाता है. दैट श्रिंकेज ऑफ प्रोटोप्लास्ट इज़ नोन एज प्लाज्मोलिसिस. उसी को कहा जाता है प्लाज्मोलिसिस. सो इट इज़ अ प्रोसेस ऑफ कॉन्ट्रैक्शन और श्रिंकेज ऑफ प्रोटोप्लाज्म ऑफ अ प्लांट सेल व्हेन इट इज़ प्लेस्ड इन अ हाइपरटोनिक सॉल्यूशन. Hypertonic means more concentrated solution. So the stage of plasmolysis, when protoplasts just start to pull away from the wall, it is called incipient plasmolysis. So we can say simply the initial stage of plasmolysis, जब साइड से ये जो मेम्ब्रेन है वो सेल वॉल से डिटैच होना शुरू होती है. So that initial stage of plasmolysis is known as incipient plasmolysis. Then if we will place this plasmolyzed cell in hypotonic solution, that is less concentrated solution, then this cell will regain its original shape and size and becomes fully turgid, and this process is known as deplasmolysis, और इसे कहा जाता है deplasmolysis. The next important term is water potential, and it is denoted by a Greek sign that is called psi. So this symbol is used to designate the water potential, that is psi W. This water potential is the free energy, or we can say the potential energy, which is present in the water molecule, that is called its water potential. So this term was coined by Slater and Taylor in 1960. And it is the potential energy of water per unit volume related to its pure water when we consider it in reference. तो जो प्योर वाटर है उसमें जो फ्री एनर्जी प्रेजेंट होती है, पोटेंशियल एनर्जी, दैट इज बेसिकली द वाटर पोटेंशियल. सो हियर वी कैन सी in this left hand side tube there is pure water, and its maximum water potential is, its value is 0. If we add some solute in this water, so the solute particle will lower down the water potential or free energy of water molecule. So that reduction in free energy of water is known as solute potential. That is the solute potential, and here the value of water potential is in negative. So water potential value for pure water is 0, and for solution such as contents of cells, water potential is determined by 3 major sets of internal factors, which include matrix potential, solute potential or osmotic potential, designated as psi-s, and pressure potential that I will discuss one by one. Next, if we want to calculate water potential, so we can calculate by using this equation. So this is psi W, which is water potential. It is equal to psi P, that is pressure potential, and solute potential. In addition to this, we can also add the values of psi M, that is matrix potential, plus psi G. But the value of these two parameters is negligible, so इसे हम ignore कर सकते हैं. So finally we can calculate by using this equation, that is psi W is equal to psi P plus psi S. So here water potential is equal to pressure potential plus solute potential. So the sum of matrix potential. So what is matrix potential? It is developed due to binding of water molecules to the cell and cytoplasm. तो जो पानी के molecules bind करते हैं cell के cytoplasm में, उसकी वजह से जो potential create होता है, that is called matrix potential. Then solute potential is the potential of solute that reduces the water potential, means कितना water potential को reduce किया है, that is called solute potential. And then pressure potential, which is the hydrostatic pressure, जो कि पानी की entry से develop होता है, which by its effect on the energy component increases the water potential. So simply this is the equation, that is psi W is equal to psi S plus psi P, that is solute potential plus pressure potential plus matrix potential. In addition to this, there is another potential that is called gravity potential, and this is applicable for the plants of height beyond 5 meters. तब हम इसे consider करते हैं. The next is diffusion pressure deficit. So this is a synonymous term to water potential. इसे और suction pressure भी कहा जाता है. So this term was coined by Mayer in 1938, which is synonym with water potential, synonymous with water potential. It has positive value, जबकि जो water potential है उसकी value negative होती है, and for pure water that is 0, पर ये जो DPD है इसकी value होती है positive में. फॉर एग्जांपल 5 एटमॉस्फेयर, और इसको हम मेजर करते हैं एटमॉस्फेयर में, वाइल जो वाटर पोटेंशियल है दैट इज मेजर्ड इन केस इन bars. So diffusion pressure deficit is the reduction in diffusion pressure of solvent in a system over its pure state. It means जो solution है उसमें solvent का जो diffusion pressure decrease हुआ है, reduce हुआ है as compared to the pure solvent जिसमें कोई भी solute नहीं है. So that reduction in diffusion pressure is known as dPd. If we want to calculate this dPd, we can calculate by using this equation, that is dPd is equal to OP minus Tp. So osmotic potential minus or osmotic pressure minus turgor pressure. So इसे हम calculate करते हैं dPd. In fully turgid cell, its value is 0 because here osmotic pressure is equal to turgor pressure. In fully flaccid cell, it is again 0. Here dPd is equal to osmotic pressure. So water is absorbed by a system having higher dPd from another system with lower dPd. So simply जिसमें डिफ्यूजन प्रेशर डेफिशिट जितना ज़्यादा होगा उस तरफ को पानी मूव करेगा जहाँ पे dPd की वैल्यू कम है. So we will understand it with the help of an numerical values. Here there are two cells, that is cell A and cell B. In case of cell A, here this osmotic pressure is 8 and turgor pressure is 4. So if we will minus this, so we will get this dPd is equal to 4. In cell B, this osmotic pressure is 10 bars and turgor pressure is 8 bars. When we will minus this, we will get this value, that is 2. So here the value of dPd is less and here the value of dPd is more. So here the deficiency is more, diffusion pressure is deficit is more, so water will move from cell B to cell A. So this is the line that explains that water is absorbed by a system having higher dPd from another cell with lower dPd. So this cell has higher dPd value as compared to this cell. So dPd is equal to OP minus Tp, where all the terms are with positive values. इसमें जो value है dPd की, that is in positive terms. The next comes difference between this dPd and water potential. ये दो चीज़ें हैं, दो terms हैं, but these are synonymous. So dPd was originally called suction pressure, इसे suction pressure भी कहते हैं, while this water potential, where psi and chemical potential, which is the chemical potential of water, that is equivalent to dPd with positive value, with negative value, sorry. जो dPd है उसकी वैल्यू होती है पॉजिटिव और जो वाटर पोटेंशियल होता है उसकी वैल्यू होती है नेगेटिव में. And this dPd is measured in atmospheres while this water potential is measured in bars. dPd is the difference between diffusion pressure of a solution over its pure solvent. Means solution में जो solvent है इसमें dPd ज़्यादा होता है as compared to जो pure solvent है. Then water potential is the difference between free energy of water molecules in pure water and solution. We can calculate dPd by this equation, that is osmotic pressure minus turgor pressure, while OP is osmotic pressure and Tp is turgor pressure. While this water potential is calculated by using these terms, that is metric potential plus solute potential plus pressure potential plus gravitational potential. This psi s is solute potential and this psi p is pressure potential. So these two terms are used for calculating this water potential. Water moves from lower dPd to higher dPd, that I have already discussed. Next comes solute potential. It is also called osmotic potential. So this is simply जब हमने इस प्योर वाटर में सॉल्यूट ऐड किया तो इसमें जो वाटर पोटेंशियल है, जो फ्री एनर्जी है वाटर की, वो डिक्रीज हो जाती है, रिड्यूस हो जाती है. सो कितना वाटर पोटेंशियल कम हुआ है सॉल्यूट के ऐड करने पे, दैट इज कॉल्ड सॉल्यूट पोटेंशियल. उसे कहा जाता है सॉल्यूट पोटेंशियल. सो इट इज डिफाइंड एज द अमाउंट बाय विच वाटर पोटेंशियल इज रिड्यूस्ड एज अ रिजल्ट ऑफ एडिशन ऑफ सॉल्यूट. तो सॉल्यूट ऐड करने पे कितना वाटर पोटेंशियल कम हुआ है, दैट इज कॉल्ड द पोटेंशियल ऑफ सॉल्यूट और सॉल्यूट पोटेंशियल. It is always negative. The next terms are pressure potential. So it is equal to turgor pressure and is positive except in a plasmolyzed cell. इसकी वैल्यू पॉजिटिव होती है एक्सेप्ट इन प्लाज्मोलाइज्ड सेल, जिसमें पूरा का पूरा जो सॉल्वेंट है वो बाहर निकल जाता है. And in xylem vessel where it is negative. The next is metric potential. It is used for surfaces of or colloidal particles लाइक वी हैव प्रोटीन, स्टार्च ग्रेन्स, उस सिर्फ उन पार्टिकल्स के सरफेस के ऊपर पानी के जो मॉलिक्यूल्स हैं वो अडेयर करते हैं बाय एडिशन, and that adsorption is known as this metric potential. It is also negative. For example, soil particles, cell wall के जो components हैं, cellulose होता है, hemicellulose होता है, pectin substances होते हैं, cytoplasm etc. The next is gravity potential, designated by psi g. It denotes the effect of gravity on this water potential, and it depends upon the height of water above the reference state of water, the density of water, and acceleration due to gravity. So ये factors हैं जिनके ऊपर ये depend करता है. In case of plant cell, value of delta G is negative, इसीलिए हम इसे ignore करते हैं. Up to height of 5 meters from the reference level, and so also the value of metric potential is ignored. तो जो हमारे पास water potential की value आ रही है, that is water potential is equal to solute potential plus pressure potential, क्योंकि ये जो दो values हैं gravity potential और metric potential की, these are negligible, so they can be ignored. So that's why we can see here this water potential is equal to solute potential plus pressure potential. If two systems, there is conclusion, if two systems are in contact, water moves from the system with higher water potential to that with the lower water potential. Simply जहाँ पे water potential ज़्यादा होगा, suppose this is a pure water, यहाँ पे water potential ज़्यादा है तो पानी यहाँ से move करेगा उस तरफ को जहाँ पे water potential कम है. So this movement is known as osmosis, simply through a semi-permeable membrane. We can explain it in another terms. So there is or less negative water potential to more negative water potential. तो यहाँ पे जो water potential है वो less negative है, यहाँ पे ज़्यादा negative है, more negative, so water movement will occur in this direction. So by this way we can understand this concept of water potential. So this was all about for our today's discussion about these topics. Hope you will get some idea from this presentation. If you have any questions, queries, and any suggestions, you can give it in comment section. Thanks for watching. Have a great time.